Good morning, Kevin here again. Still living off grid, going on 2.5 years. I want to do a little video about my underground temperature sensing setup. I needed to find out what the temperature is at various depths going down to around 20 feet. So I had to design a thermometer and a way to measure the temperature at different levels. So I made a little box here. I'll show you how it works later. Design the box to be able to test a temperature sensor at 17 feet, 13 feet, 9 feet, and so on up to the top. I'll show you the components and how I put it together. It's a pretty small audience that's going to appreciate this. I'm sure a lot of people don't want to know what the temperature of their soil is 15 feet deep, but I wanted to know because I did a geothermal air conditioning system, like an earth tube type system, and the one I made worked, but I didn't get it quite as deep as I wanted to. I've only got mine at a little over 9 foot depth, and after I put my system in, I thought, well, I need to find a way to figure out what's real here and what's not, and so I did this. So here we go. This may get a little bit wonky for a minute, but these are the main components, especially this little temperature sensor. It's what everything revolves around. It's a little analog temperature sensor, a TMP36GZ. It was acquired from Adafruit for about $2.50, no big deal. It has a 3-pin connector. One side is a positive, the other side is a ground or negative, and the center pin is an analog voltage output. When you connect the analog voltage output to the ground, that'll give you a reading up on the surface that you want to read in millivolts. And then you'll take those millivolts and subtract 500 and divide by 10, and that will give you your Celsius reading. You can then convert to Fahrenheit, which is what we deal with around here. This little sensor requires a 2.7 to 5.5 volt input voltage to make it work right, and its service range is well within what we needed. I think this is like 40 below, negative 40 centigrade to 125 centigrade, so it's no problem to getting what we need. The idea is to embed this into some thermally conductive potting compound inside this fitting that screws into this 3/4 inch PVC fitting. And in order to get these 3 pins up to the surface, I found a little female pigtail connector, little tiny wires on it that you can put the pins into the connector and then put it in the potting compound. And so that'll give you your positive and your analog output and your ground. And that's really all you need to make this work. I'll show you how I set up the junction box up at the top to get readings from each depth, and you can make as many of these as you want and put them at whatever depth you want. So here's the electronics to measure the voltage coming up from the sensors. It's an old electrical box that I had left over from a job, or pulled off an old job for breakers. And here's the gear. As I mentioned, these sensors require 2.7 to 5.5 volts to operate. So I took 2 AAA batteries, wired them in a series, which doubled their voltage. And I think they're 1.3 volts each. And then ran the positive over to a toggle switch that puts power down to each one of the sensors. And they're all wired in line, and so is this negative that comes back up to this same battery pack. These are all the analog voltage output wires here that are coming up out of the ground, out of this PVC pipe here that goes down and down underground over there where the hole was. So you could just take your multimeter and test between any one of these and the negative, and that would give you your reading. But I just put a cheapo multimeter in here so I could keep it in place and use push button switches to get my millivolt readings here at every particular depth. This is 16 inches, 5 feet, 13 feet, and 17 feet. Pretty simple. It doesn't need any external calibration for these sensors to work. You just got to put power to them, and then, as I said earlier, that you just contact the center pin on the sensor to the negative or ground, and that'll give you your voltage reading, and you can convert that to Celsius. I dug my hole fairly close to this telephone pole. Now, you don't have to have a telephone pole to put this on. You could put it on a little fence post or whatever you wanted to. I just happen to have one here because this is where my old meter box was. If I wanted to continue being fleeced by the electric company, this would have a meter here, and then there would be a disconnect, and I would have electricity run to the house. But as I mentioned in an earlier video, I don't do that anymore. The hole was over here about 6 feet away from the pole, and I dug it with a little hand auger. The auger I bought from the hardware store. This was the costliest part of this whole setup. It cost me about $130. It has a threaded pipe handle that threads into the auger head, which allowed me to add extensions in between by fabricating an end with a 3/4 male and the other end a 3/4 female to attach and add a length of extension on as the deeper I went. And I understand that I got really lucky in that I don't have a lot of rock in this area, and it was fairly easy digging, bringing up one auger at a time. Took me about 6 or 8 hours of total digging time, but I spread that out over a couple of days because I'm old. And I'll add in a couple of clips of me doing the digging. This was about a year ago. Once I got the hole dug, I dropped my thermometer, sensor set up down in the hole, and once it was all watertight and encased in PVC, then I could backfill the hole. And when I backfilled the hole, I just made sure that as I was putting the dirt back in the hole, that I wet it down so there wasn't any void, so the soil could be right up against the sensors and give me an accurate reading. I dug down to 17 feet. I probably didn't need to go quite that far, but I wanted to go, and I kept going until I hit bedrock, which is highly unusual for most parts of the country. I understand if you have bedrock, it's going to be much harder to try to do one of these. You may have to hire a driller to come out and drill a little hole for you, or buy one of those lawnmower engine powered well units, or rent one or something to get a hole in the ground. But for me, this is the most cost-effective way to do it, and it worked fine. So after it was all said and done, this is the data that I collected over a year's time with my thermometer setup. And as you can see there on the top line, you got the date, the time, outside air temperature, the various depths of the sensors that I put down, 16 inches, 5 feet, 9 feet, 13 feet, and 17 feet, and the readings that come off each of them. Now, when I first went off grid and moved out here full time, I didn't know how I was going to do this thermometer thing at all, and I was in a hurry to get some cool air coming in the cabin, so I built my system, and I put the depth at 9 feet, which you can see here. And these readings are what the air temperature is coming out of the pipe out from my intake that's coming through the earth tube system. And so that's why it's not a sensor at 9 feet. It's actually the temperatures that are coming into the cabin, which tells me, you know, that's what the ground temperature is out there. And I realized I should have done this first, but I just couldn't take the heat. I put my entire system in. It cost me around $2,000 for the whole thing, but it was well worth it because it's been working well over 2 years now, and it works as an air conditioner in the summer and a heater in the winter. As you can see, here's your outside air temperature, and here's what's coming into the cabin. So you got December, it's 50 degrees outside, and I've got 70-degree air coming in. January here, same thing. We had very moderate temperatures this year. 47 there, 64 coming in, a little cooler that day. It's really pretty stable, as you can see. June, it was 95 outside. I was getting 73-degree air into the cabin. And each one of these are the measurements of the soil temperature here. These 4 here. And I know it's clunky, and it was really the only way I could show to put it on a graph and measure it so I could look at it and see exactly what was happening. And so now I know my next system I'm going to put in at 13 feet. That way I'll have a much more stable temperature. That's going to be the air coming into the cabin when I get the pipe down a couple more feet in my next system that I put in. But like I said, I was in a hurry, and you know, heat stroke was definitely an issue working out here, and you got to have some way to keep yourself cool. I know better now. I'd like to thank everybody who's tuned in, giving me a like or a sub. Much obliged. There was no information anywhere on how to build one of these, so this was all trial and error. It worked out okay. Want to give a special thanks to Joey White, young man, very fine engineer, who helped me put this system together. Without him, it would have been a lot tougher. Next video, I'll go over the geothermal earth tube air conditioning system that's already in the ground. It's been working for 2 years. This little box here now gives me more knowledge about what the exact soil temperature is at given depths. My first system I put in at 9 feet, just using anecdotal evidence. It turned out to be okay, but I don't get my 70-degree air in year-round. In the summertime here in Texas, when it gets so hot, the soil, even at 9 feet deep, will get up to 80 degrees. 80 degrees is a lot better than 120 degrees, 110 degrees outside air temperature coming into the cabin. So it's been a lifesaver. My next system that goes in, though, I'll be at 13 feet. And that'll be much more stable for me. Thanks again. Everybody have a great day. See you on the next one.